So, welcome to the 6.5 notes on SSS and SAS similarity. And so, if you remember from last time, we learned a shortcut to prove triangles similar, right? We recall that if two triangles are similar, the definition is that we know that corresponding angles are going to be congruent and that corresponding sides are going to be proportional. And I tried to make this connection back with Chapter 4. Remember back in Chapter 4, with congruent triangles, remember that means all the sides and all the angles are congruent, we had some shortcut postulates and theorems, SSS, SAS, ASA, AAS, and HL, that would prove for us the triangles are congruent without using the full definition. Again, we learned one of the kind of same ideas for similarity last time, and that was AA, right? AA similarity, right? So if we wanted to prove two triangles are similar, we'd have to show all three corresponding sides proportional and all three corresponding angles congruent. Again, just like Chapter 4 with congruent triangles, though, we have some shortcuts. So last time we talked about AA. Today I want to talk about the other two, which would be SSS similarity and SAS similarity. SSS and SAS. And so let's jump to our theorem sheet to write those down. So our theorem sheet, let's come to the bottom here. So what SSS is saying, it's not the same as congruency, it's SSS similarities. I'll write the tilde there. If the corresponding side lengths are proportional, right? Proportional, then the triangles are similar. In other words, I don't need to see all the angles. Let's say, I'm going to make numbers that don't quite scale, but let's say this is like 3, 4, actually no. Let's say this is like 3, 4, and 5, right? This is 3, 4, and 5, and let's say this is 9, 12, and 15. Okay, so since all these sides are proportional, right? 12 divided by 4 is 3, 9 divided by 3 is 3, 15 divided by 5 is 3, right? This to this equals this to this, and it equals this to this. They're all proportional. Then I can say that triangle ABC is similar to triangle RST, right? In other words, I don't need the angles. All I need is the sides to be proportional, and I can claim the triangles are similar. To the back, same thing holds for SAS. So SAS similarity. SAS similarity. So if I have one angle, right, that's the included angle, right here, congruent. So if the angles are congruent, so one corresponding angle, and then two sides that are, around it are proportional, then the triangles are similar, right? So it's the same idea. So if I have one of these angles congruent, and let's say this is 4, and this is 2, and this is, I don't know, 6, and this is 3, right? So if these are congruent, and then 4 over 2 is 2, 6 over 3 is 2, so it's proportional, right? So ZX over PM is the same ratio as XY is to NN. Then I can say that these triangles are similar. Triangle XYZ is similar to triangle PMN. Oops, sorry. MNP. Okay? So I'll post these GeoGebra links here, but it's we can just explore it just a little bit. So again, SSS similarity, SSS similarity says, there we go. So again, if I've got this over this is the same ratio as this over this is the same ratio as this over this, you can see they're all just 2, right? It doesn't matter if I don't know the angles. I can actually show them. Look, underneath, the angles are congruent. So I don't need the angles to prove two triangles are similar. I could just have the sides proportional, and that would be enough, right? I could change this around. I could make the scale factor different, so I can make it like 2.5. But if I check the angles, yep, the angles are still going to be congruent. So in other words, it's enough to just have SSS. Same thing with SAS. So again, look, I've got two sides proportional, right? 2 to 1, 2 to 1, right? It's the same fraction. And then the included angle is congruent. Is that enough to make these similar? Well, if I check, look at the other angles. Yep, angles are congruent. Show the other side. Yep, this is half of this. It's just off because of the rounding, but it, excuse me, it is proportional. So in other words, it is enough to just have two sides proportional and the included angle. And of course, I could change around the angle if I wanted. Let's see. I could change the angle. I could change the scale factor. So let's make it 1.5 instead. And it doesn't matter. If I show the third side, I show the angle, yep, everything checks out. So SSS or SAS are sufficient to prove triangles similar. Okay, so, and again, don't forget the sides are proportional, not congruent. That's what we're looking for. All right, so let's do some work then to check out how do we do this then? How do we apply these theorems? Remember, we have three choices now for similarity, three shortcuts, AA, SSS, and SAS. Let's check here. Are these, is this triangle, DEF, or GHJ similar to ABC? Okay, so let's compare. First off, let's compare ABC to DEF. All right, so let's check. Notice that I have no angles here. I have no angles given. There's no 90 degrees, no nothing. So I can't use, right, I'm just saying, hey, check if they're similar, but I can't use AA, right, because there's no angles given, and I can't use SAS either, right, because that would require some angle, and I don't have that. So we are checking, we're going to check SSS, right? We're checking, are all these sides going to make similar, are these sides all proportional or not? So since we don't have anything to kind of guide us, they might be rotated, let's just look for the shortest sides first. So we're comparing this to this. What's the shortest side? Okay, that's 8 for this one, and the shortest side here is 6. So 8 over 6. And let's check the longest sides. That'd be 16 over 12. And the medium side would be 12 over 9. Okay, what I like to do is I just put little equal signs here and put a question mark. Are these all the same fraction, really? Are they all proportional? So let's divide by an equivalent form of 1. Let's see what works with here. 2 over 2. Okay, what works here? 2 works, but 4 also works. And 3 over 3 works as well. So we're just dividing by 1. We're not changing the number. And what do we get here? We get 4/3. We get 4/3. And we get 4/3. Okay. So all three sides are proportional, and by the SSS similarity postulate then, therefore, these are similar. Yes, they are similar. Okay, let's compare this one to this one now. Same idea. Let's check the short sides. So 8 over 8. Right, 8 is the short side here. 8 is the short side here. Let's check the longest sides. 16 over 16. Okay. And the medium sides, 12 and 10. All right, so we're checking. Put equal sign, put a question mark. We're checking, hey, is this to this the same ratio as this to this and this to this? Well, we can clearly see this is just 1. This is 1, and this is clearly not 1. So because the sides are not proportional, we can say no, they're not similar. Okay? All right, so why don't you try then to do this kind of simplification here. Which one of these triangles are similar? Why don't we take out part B here? Let's see, part A. Why don't we just check? Why don't we just check part A? Why don't we check is, I'm going to rewrite this, is LMN similar to, what would that be? RST. Okay, and then part B, let's compare LMN. Is that similar to ZYX? Okay, so first off, let's compare triangle LMN to RST. Okay, and then let's compare LMN. Wait, hold on. I think I might not have lined these up. LMN, so that's the short and the medium one. RST, yeah, sorry, it should be SRT. SRT, excuse me here. SRT. And let's see, LMN, so this should be, let's see, YZX. YZX. Okay, so go ahead and first compare these two and then these two. Pause the video, see if you can get an answer, either yes or no. Think about whether you'd use AA, SAS, or SSS. All right, so hopefully you've checked. Remember, we have 3 possible ways to check for similarity. We could use the definition, but since I don't have enough information here, I can't use the definition, so I have either AA, but let's look. I do not have angles given here, so AA is out. SAS also requires one angle in the middle. The included angle be congruent. I have nothing given there, so really we're just checking SSS. Are all the sides proportional? Okay, so let's check SSS. All right, we're going to check SSS, similarity. So let's compare the short sides first here. So 20 for this one. 20 to 24. Is that, so put a question mark, is that the same ratio as, let's check the long sides, 26 to 33? And is that the same, let's check the medium ones, as 24 is to 30? Okay. Okay, so we need to reduce this down to see. Let's see, 20 and 24 can both be divided by 4. So divide by 4 over 4, equivalent form of 1. 26 and 33 I could divide by, let's see, 2 does not work. 3 does not work. 4 does not work. Let's see, 11 would work here, but that doesn't work here. This can't really reduce, and so what we see here is this is going to give us 5/6, and this is 26 33rds. This is clearly not equal, so these two are not similar. Not similar. Okay. If you were unsure of what to do now, but this helped you, you can pause the video again and try to check if LMN is similar to YZX. All right, so if you've done it, let's check it out. Let's compare. Let's see if the sides are proportional. So 20 is the short one compared to, that would be 30. Question mark, is that really the same ratio as the long one, 26 to 39? And is that the same ratio as 24 is to 36? Okay. So let's divide by an equivalent form of 1 here. What can we divide this by? Well, 20 and 30 can both be divided by 10. Right? 10 over 10 is an equivalent form of 1. I get 2/3. Okay, 26 and 39. 2 does not work. 3 does not work. If you were thinking I can't reduce it, let's see here though. Actually, there is something we can do here. If you keep going, if you think about it, 26 can be divided by 13, and so can 39. Let's divide by 13 over 13, equivalent form of 1, and we get 2/3, but it still might not work. Let's check the last one. 24 and 36 can be divided by 12 over 12. Divide by 12 over 12, and I get 2/3. So this one, all sides are proportional. This to this is the same ratio as this to this, which is the same ratio as this to this. All sides are proportional. We don't need to know the angles, just like with the GeoGebra demonstration. Though if we wanted to see it, we could fill it in. Right? All the angles would be the same, so these are similar. You can say yes, similar by SSS similarity. Okay, moving along here. Let's just do 3 and 4. We won't do 5. This one I just included here because it was kind of helpful. Sometimes it's helpful to redraw things, like you can rotate them around because rotations does not change the figure, to orient them the same way. Let's see if the triangles are similar. So why don't you try 3 and 4, take about 4 minutes or so, 3 and 4. Tell me, are they similar by AA, SSS, SAS, or are they just not similar? The answer could just be no. So go ahead and pause the video and try 3 and 4. We won't do 5, just do 3 and 4, and then we'll check it out when we come back from this. All right, let's take a look. Are the triangles similar? So in this case, I've got this kind of shape here. So I can add vertical angles. And that was important. Why? Because look, AB and ED are out. Like there's no information, right? If you remember, here are our choices. We've got AA, SAS, and SSS. We've been using SSS, but look, I don't have this side length. I can't use, I don't know what it is, so I cannot use SSS because I don't know the third side. AA, I've got one pair of corresponding angles, but you know, these are not parallel. I can't add alternate interior. I just don't know. I don't have a way to add another corresponding pair of angles. So the last one to check is SAS. Let's check SAS similarity. In other words, I've got an angle in the middle. Let's check if these are proportional or not. So let's check. I could either go from here to here or from here to here. So 9 is the shorter one, and that would go with 15. Is that question mark equal to 18 over 30? Right, so the shorter one to the shorter one, the longer one to the longer one. Let's see if it's actually the same thing though. Let's see, 9 and 15 can both be divided by 3, so I'm going to divide by an equivalent form of 1 here. 18 and 30 can also be divided by 2, that works. 3 works as well, so when 2 and 3 both work, that tells me, okay, that 6 is probably actually a better choice. I'm going to divide by 6 over 6. And so what I get is, this ratio is 3/5, and 18 divided by 6 is 3, 30 divided by 6 is 5, so I get 3/5 and 3/5. Okay, so what situation do we have here? We have two sides proportional, right? This to this is the same ratio as this to this, and I have the angle in the middle included as congruent, so I can say yes, similar by SAS similarity. Okay, if that helped you, you can try the last one now, or we're going to show it in about 3 seconds. Okay, number 4. So this one, actually, we have 2 options. So AA, we don't have a way to add another angle here, so AA is out. SSS, you could actually do it because these are 90 degrees, so you could do the Pythagorean theorem and find this third side, but that's just too much work. Really, though, it's really set up because I've got 90 congruent to 90, and I've got the sides surrounding that angle, right? The angles included between these sides given. I can just check SAS again. Check SAS. So again, I'm going to check. All right, 24. 24 is the shorter one. Going to 18. Question mark. 28 to 21. Okay, so 24 and 18 can both be divided by, let's see, 6. Okay. 28 and 21 are both divisible by, let's see, 2. That doesn't work. 3 works for this one, not for this one. 4 works for this one, not for this one. 5, no. 6, no. 7. 7 works for both. 7 over 7. Dividing by 1 really is all we're doing. So we get 4/3 here. And we get 28 divided by 7 is 4, 21 divided by 7 is 3, so we have 4/3. So again, we have the included angle congruent, and we have the included sides similar, or excuse me, proportional. So yes, I could say yes. Let's actually write the similarity statement. Triangle SRT is similar to triangle PNQ by SAS similarity. Okay. If you chose to do this one, X, Z, W, Y, Z, X, this one is just a little bit more confusing because it's kind of have to rotate them, but all you'd have to do is, okay, like compare 9 is the short one on this one, and you look who is the short one over here, that would be 12, right? So the short one for this triangle, the black triangle, is 9. And 12 is the short side for this one. I'll do that in blue. Yeah, since I'm doing it, might as well just do it. Let's check here. The medium one for this one will be 12, the black one. The medium one for the blue one is 16. And the longest one for the black one is 15. And the longest one for the blue one is 20. Okay, question mark, question mark. So I'm checking SSS. I'm checking SSS, right? So short to short, medium to medium, long to long. If I divide by 3 over 3, I get 3/4. If I divide by 4 over 4, I get 3/4. If I divide by 5 over 5, I get 3/4. So this one, I say yes by SSS, or if you looked at it carefully, you got 90 and 90, so you could have actually ignored these two and just checked SAS. That would also work. So sometimes there's more than one solution to these problems, but in general, your answer is either going to be yes, they are similar by AA, yes, similar by SSS, sides are proportional, yes, similar by SAS, or just no. All right, go ahead and try the work.